Good morning, good afternoon, and good evening, everyone. I am very happy to have all of you at the Global AI Community on tour. And we are ready to kick off with the next speaker. And I think he's already here. Hi, Ari. How are you? How's it
Hi, how's it
going?
going? Thank you for having me. I'm happy to be here.
Yeah, we are also very happy for you. So, where are you broadcasting from
So
now?
I am broadcasting from my apartment that I've been in for a month in Tel Aviv, and I'm excited to be here again.
Cool. And what is the time over there right now?
It is 10 a.m., so
Oh,
we're a little bit luckier than some of you. We appreciate that people are coming out so early.
that's actually pretty close to our time zone. I am in Denmark and it is 9 o'clock right now, so it's very close.
Amazing.
So, Ari is an open source engineer at Microsoft and has a passion for AI and history. And he collaborates with the Israeli high tech community to solve real world problems with game changing technologies that are then documented, open sourced, and shared with the rest of the world. And your topic today is going to be about unsupervised aspect based sentiment analysis at scale. So
Yes.
this
So
sounds very interesting.
it's going to be very interesting. We're going to be talking about some of the technologies that we collaborated with Intel here in Israel to develop in the natural language processing space and how they can be applicable to getting more robust insight into your language data. So I'm excited to present that.
Yeah, it sounds really interesting. And just so you know, guys, you are welcome to ask questions throughout this session, which will be asked in the end of it. And feel free to go to chat.globalai.community where you can post your questions. So, Ari, are you ready to take it away?
I am ready. So let's
Cool,
get
then the
started.
stage is yours.
Amazing. All right, perfect. So let's get started here. Before I get started, I just want to say hey, thank you for having me here and just a little bit about myself. So, as was said, my name's Ari Bornstein. I'm an open source engineer for Microsoft, and I work a lot in the machine learning space. Um, if you're interested in learning a lot of what that means is that we develop a lot of open source solutions like the ones that I'm going to be presenting today, collaborating with different research institutions and startups in Israel. And then we go and we travel and we share the learnings all over the world. One last really personal note is this month, Microsoft and the cloud advocacy team is working on an initiative called AI April, where in addition to the amazing work that's being done by the Global Bootcamp, every single day there's going to be a piece of new, interesting AI content. So I encourage after today, after you're done with all the amazing sessions, to go here to aka.ms/AI April to learn more and see the amazing stuff that we're building. Um, with that, let's get started. So one of my areas of expertise and research is the field of natural language processing and language understanding. And when we look at this from an industry view holistically, we're seeing three main industry trends in this space. The first one, super exciting, is the area of ambient computing. Think Cortana, Alexa, but also the HoloLens too. And it's thinking about how we can use natural language to interact with the environment around us. How can we uh, look to communicate with objects that might not necessarily be there, or how can we also communicate with devices so that we can better get information or interact with the world? The next area is that we're seeing a lot of development and a lot of interest in natural language processing technologies is the concept of automation and scale. Today, there are a lot of very bureaucratic, long processes, whether that's filling out uh, long forms, even though we have some of that information, whether that's sorting information. So, for instance, you can imagine in a legal office or right now in a medical office having to go and have a doctor sort multiple forms into different categories or reading different research articles and putting them in different categories. That can be a very slow process. And also you need domain experts. If we can build stronger language understanding solutions, it enables us to automate that process so that we can scale our impact, especially in areas like legal, in the legal sense, accounting, CRM, and additionally in terms of working in the medical space, which I think is super critical in these trying times. And the last area, which is my personal favorite, is being able to unlock unstructured data so that we can have better features for building more robust AI models across the board. When we look at most of our systems and how we communicate today, a lot of the information we have isn't just in tables with numbers like we often model in machine learning. A lot of it is in unstructured data, whether that's images or text, and being able to extract that insight into text so that we can build stronger models is critical. And we're going to be talking more about this part of AI today. Um, I want to get started by giving like a quick demo of text analytics and some of the cloud services that enable this type of thing. So let's jump over to my browser here. I'm going to go into text analytics, and you can see we have some text here, and I'll explain kind of what this service does. What the service does is at a very high level, it enables you to put in this unstructured data and get structured features that we can then use to make more robust models. So I can put in text, I can understand what language the text is, I can extract key phrases that I can maybe build rules, or I can use those embeddings based on those phrases to make stronger models. I can get information like the sentiment at the document level, at the sentence level, and I can also get named entities. So if I want to extract things like dates, and I want to extract things like locations, I get all that information. I can even extract out personally identifiable information. So you can imagine in like a medical setting, this is really, really critical, being able to go in and get, understand what's the information that I want to protect from a privacy perspective so that I can process the rest of the information so that we can make more robust models. We have linked entities, so we can link specific things, like for instance, a steakhouse or New York City, to additional structured data that can be very, very strong. And what's really powerful about these services is, in addition to getting all that information that can be structured and featureized for providing context to our models, it also gets returned to us in JSON. And if we look at some of the strengths of these services, they can be consumed with REST-based APIs or APIs in pretty much each of the platforms we use today, whether that's Android or Windows or iOS, and also across all the languages that we're comfortable building with. They're also supported by the developer community. And so when we look at these, the reason I want to start here is when we look at these things, I like to say that when we're building AI solutions, it's important to think about an 80-20 rule. Now, an 80-20 rule is called a Pareto optimal, and there are many of these in the field of computer science. One of my personal favorites is the one that we all learn, which is 20% of your code is responsible for 80% of your bugs. In the AI setting, I like to say that 80% of the scenarios that you want to do today are probably supported by out-of-the-box solutions that are being constantly supported and maintained. And for those 80% of the scenarios, I strongly suggest that it's worthwhile evaluating these out-of-the-box solutions. That being said, there's also a remaining 20%. And what's interesting is these 20% of scenarios need a much more custom approach. You need to be able to, this is where you need your data science and your machine learning engineer. This is where you need to drive deep. And what I think is most interesting about this 80-20 split is it tends to be that 20% is the 20% that provides the most business insight and business impact when we're talking about digital transformation and the impact of AI. So how do we address this 20%? So today I'm going to be talking about one potential solution using, when we're talking about production scale, with the Azure Machine Learning Service, which is a mixture of two things. It's a mixture of a set of cloud services and unified by a unified Python SDK. And it enables you to do all these different things, from data preparation to training models to managing a huge data science team, scaling, deploying models at scale, and then getting that feedback end to end. Now, in order to understand this, we're going to look at a specific scenario, and I'm going to show you an example of this 80-20% split. So let's go back to our cognitive service, and I'm going to give a perfect example of this. So imagine I'm a company right now, and we're going to build we're a retail company, we have an online platform, we get all these reviews, and I want to identify the sentiment of these reviews so I know what products and inventory people like and what they don't. So I can take a piece of text like, I loved the pants I ordered. Now, these are US pants, not British pants, just to be clear. If I click analyze, you can see very quickly I get positive, and that's very powerful. But where sometimes these types of systems that are pre-built, even though they're very powerful and very generalizable breakdown, sometimes there are use cases that are a little bit more complex. So for instance, if I say, I loved the shirt I ordered, but I hated the pants, all of a sudden I'm going to get an interesting result. Now, I'm not going to reveal it right now, but let's talk about some of the different options. So I could either get a positive result because I said I love the shirt. I could get a negative result because I said I hated the pants. I could maybe assume that these love and hate will balance out and I'll get a neutral result. But the reality, are any of these solutions correct? Not really, because what we're really talking about is two things that are encapsulated in one piece of text. And so if I were to click analyze here, you'll see that we get a negative result because the way that these models work is they put a stronger weight on words that occur more. And if we're looking in a review setting, often people leave negative reviews more than they leave positive reviews. Now, again, it's not that the sentiment analysis isn't very powerful for this 80% use case, but if we want to dive deep and actually have more granular insight, we need to dive deep and we need to look at this 20% use case. And so that's what we're going to be doing today. We're going to be demonstrating how we can use the NLP architect developed by Intel and supported by some of the work that I've done here with Microsoft to develop a aspect-based sentiment analysis model that enables you to identify what are the different aspects, whether that's the pants or the shirt, and get individual sentiment scores for each of these aspects that then we can use to get more granular insight. So let's quickly go back to my browser. We're going to look at NLP Architect. ABSA, you can find more information here about the model and how it works. One of the things that's very powerful about this model is it's an unsupervised model. So instead of having to annotate a lot of my data, I can just provide a large list of reviews, and it will learn how to break up the data into different aspects and how to classify the sentiment of each of these aspects. Let's get back. One of the things about this model is it's an open source model. So prior to this work, there wasn't really an example of how I take this open source project and bundle it up in a way that I can deploy in production scale. And so we're going to use the Azure Machine Learning Service to do that. But to use the Azure Machine Learning Service to do that, we have to take a look at the machine learning process. Typically at Microsoft, we look at the machine learning process as broken down into three main phases: data preparation, experimentation, and deployment. For this talk, we're going to be focusing mainly on experimentation, though I also have a lot of content and posts talking about data preparation and deployment as well. If you're interested in them, I recommend you to reach out to me in the comments or on Twitter or on Facebook or LinkedIn afterwards. And before we get into this, we should ask ourselves the question, why should we even consider using a cloud AI platform like Azure Machine Learning Service to solve this solution, to deal with this process. And I think in order to do that, we need to think about the main challenges that we go when we transition from research AI to actually production AI. So the first thing is managing environmental dependencies. When I'm working in a research setting, often I'm working on one machine and I maintain everything on my machine, but when I want to go to deployment, figuring out every package I installed and how I did everything can be a nightmare to keep track of. One of the other aspects building on this is cross-team collaboration. Often in a research setting, I'm working maybe with one collaborator, two collaborators, but in a production setting, we have a globally distributed AI team or data science team that could be just like right now where we're all working from home, which could be located across the world. And so I want to understand how can I leverage the work that other people are doing, and how can they keep track of the work that I'm doing as well. Additionally, when we think about data and compute management, so how do I manage who has access to what data and compute information? How do I manage my costs? If I were to just do things on my own and buy a huge compute cluster, what happens? It constrains me in terms of how much I can scale my model if I want to train more. Because if I need to get more, then I need to buy more hardware. But if that's a one-time operation, now I'm stuck with a lot of hardware that I don't need. And same thing for data in terms of getting storage. Another big thing that we need to think about is compliance and interpretability, not just at the data science and the machine learning stage, but also at all the fundamental building blocks. Is my storage service, is that compliant? Is my networking service, is that compliant for all the different regulations that I would think of? Things like HIPAA or FDIC. And one of the really powerful things about using cloud services is a lot of the infrastructure is already compliant. And then the last thing that we need to think about is how do I deal with distributed training and scale, and the complexity that if I were managing things on my own, like OpenMPI or all these different things, that would distract me from actually building out and training a model. And again, so ways we deal with this with Azure Machine Learning Services by providing the ability to either work on your local compute or on a single instance compute, but you also can auto scale. And we also out of the box supports distributed training services like Horovod, or even the actual distributed batching services of all your favorite frameworks, whether that's TensorFlow or PyTorch or Keras and the like. So if you're interested more about the getting started in terms of your environment, we have all the documentation here. Let's go to the next step and actually see how this works and deep dive into a demo. So the way everything works is I write the code or the model that I want to train on my computer, or I can use a VM or a cloud instance. I submit that experiment to the Azure Machine Learning Service using the SDK. Additionally, I've uploaded my data to a data store. And the next thing that I want to do is the service will create an environment using the managed dependencies that I've defined. It will link it to a scalable compute target. It will pull my data from the data store, launch an execution script to start training. And then what's really, really powerful about this service is just almost as if I was developing this code or model on my own machine, I get all the logs and outputs in real time to my machine so I can monitor my job and update my model. So let's actually look at a demo of how we actually do this. So what I'm going to do here is I'm going to go back to my browser. And the first thing that we need to do is we go to our Azure Machine Learning Workspace. This is a workspace that essentially allows me to use all the services of Azure Machine Learning. Today, the first thing that we're going to look at is creating a compute instance. A compute instance enables us to experiment. Instead of working on my local device, I can spin up a different hardware configurations that I can use as my base image. Anything from like a standard CPU device. I can also look at strong GPU devices. And what I always recommend is to start with a compute instance, get a small version of your model working, and then link it to the Azure Machine Learning Service when you want to scale. So once we have one of these running, and I have one here, we can open up. Each one of these has all the dependencies that I need in order to get started with machine learning, whether that's PyTorch, Keras, TensorFlow, scikit-learn, like we saw in the previous session. And I have a Jupyter notebook, or I can also SSH into the machine with Visual Studio Code if I'd like. And then from here, we can get started. So the first thing that I need to do is I need to set up my environment. And again, what I want to reemphasize is everything we've done here is open source, so you can get access to all these links and code yourself. So the first thing that we want to do is we want to download our notebooks, download all our configuration. We want to upload our data set to the Azure Machine Learning Service. This can be done with one line of code. So ds.upload our data set, our target path of where we want to upload the data set, and what it will do is it will pull the data locally and upload it to our data store, so then we can process it. Now that we have our environment set up, let's look at the steps of training this process.
Hey Ari, could you just
Yes.
zoom in a little bit on your notebook?
Yes, absolutely. Thank you for the
Amazing.
feedback.
No problem.
All right. So is that better? Can you guys see a little bit better now?
Yeah, that's much better. Thank you.
Amazing. Okay. So the first step that we need to do is when we're training or using the Azure Machine Learning Service is we need to connect to our workspace. So as we said, this is our Azure Machine Learning Workspace. We need to link this to the SDK. And we do this with just one simple line of code, workspace.fromconfig. Then what this will do is it will prop you, you'll get a login, you log in with your Azure account, and boom, we're ready to get started. The next thing that we need to do is we need to define a compute target for actually training the model like we saw before. This can either be in the notebook locally, or it can be what we're going to be doing here is provisioning a cluster. So in order to do this, I need to provide the cluster with a cluster name, a workspace, and then we have to create with one line of code a provisioning configuration. So again, because this model was developed by Intel, we can take advantage of standard CPU virtual machines. So I'm going to use the standard D3 V2 VM. However, if I wanted to do other models, and we have a lot of really good examples that I'll link to at the end of the presentation here, we could also link this to GPU machines to do more distributed deep learning scenarios. We can set our VM priority with just one line of code here. So I like to use low priority devices when it comes to using the Azure Machine Learning Service, because it reduces our costs and because the batch aspect of the service is pretty robust to these low priority devices. And then we just provide the how much we'd like our cluster to scale. So what this enables me to do is I can set min nodes to 0. When I'm done training my model, essentially we'll spin the cluster down and I don't pay for anything. But as the cluster is running, if it needs more resources, it can scale up to 4 instances of whatever VM size I deliver. And then just with one line of code, we can just say compute target.create. We provide our workspace, the name of the cluster that we want to create, and just this config. And then within 10 minutes, we'll have a compute device that we can use to scalably train our models. Again, I've already done this. We're not going to wait 10 minutes here. The next thing we want to do is we want to attach to our data store that we uploaded our data set earlier on. And then our environment that's all we need to set up our environment. So the next stage is now we have this environment. How do we actually create an experiment and train our model? So the first thing that we need to do is we need to create an experiment. So experiment, we provide our workspace and we provide the experiment name. I'll show you in a minute why this is so powerful, but this essentially allows us to scale and work across multiple data scientists and then keep track of all the work that we do on a specific model based on a given experiment name or on different versions of different experiments. The next thing that we have to do is we define our estimator. This is what is used to define the environment for training our model. To do this, we provide the path of where our model is. This is the scripts path, and I'll show you where this is. If we go to our code here, we have ABSA, aspect-based sentiment analysis, and scripts. We have our train and our score scripts. Let's go back 1 second. So we provide that, and that will upload all our code locally to the service to be run. We provide the parameters for our entry script, and we define our entry script. So in this case, it will be this train.py file that we'll walk in through a little bit. We can define our compute target, whether we want that local or we want, in this case, we want to run on the cluster we just created. We can also define any environmental variables, which is very, very powerful. So as we said, again, this aspect-based sentiment analysis model is optimized for CPU usage. So we can set this environmental variable to CPU, and then we don't even have to deal with any of the GPU constraints of the model. And then the last thing that we do is we set up any of our dependencies, whether those are pip packages or conda dependencies. And what's very, very cool, I'll provide an example of this here, is that we can even set these dependencies to be a GitHub repo, and then the service will build and install the GitHub repo as if it was just a regular pip or package for installation. One additional really cool feature that you can do is you can even use a base Docker image. So if, for example, you had more complex dependencies using different languages, something like C++, or maybe you have a pip package that, or a Python code that wraps software in another language like Node, you can use a base image and then you can call those packages and it will work for you. So let's actually look at what this model does. This is our train file. And what we do here is we import the NLP architect. We define a couple different parameters that we need. One is our data set. The next one is we have a couple parameters. One's called the aspect threshold. The other one's called the opinion threshold. An aspect threshold is when we're using this unsupervised model, we have words that are aspect words that we want to measure. And the threshold says that we need to see a certain number of words before we consider it to be an aspect. And the opinion threshold is likewise, these are the words that we use to determine the sentiment. We need to see, we define how many times we need to see a specific opinion word in our data set before we consider it to be a valid word for measuring sentiment. Then what we do is we use the NLP architect. We get any of the dependencies that we need, things like glove embeddings. We can uncompress them. We create our train object using the aspect-based, the NLP architect. We pass in all our thresholds. And then simply as that, we can just call train.run. And I'll get in the questions if people are more interested. I can talk about the architecture here. For the sake of time, because we're talking about how we can scale this for production, I'm not going to get into all the details of how the model works. One additional really cool thing that we can do is, even though this model is an unsupervised model, we can actually define any metrics that we want. And so we can annotate a small, and that's what I did, is I annotated a small subset of data that we can use later for hyperparameterization. And what's again really, really cool about this is in the Azure Machine Learning Service, I can define any parameter or metric that I want, and this will get visualized and can be used later for a process that we'll call hyperparameter optimization. I'll get into that a little bit later. Let's continue. So we're gonna actually show how this model gets trained. We have our estimator. All we have to do is submit our job, and I'm going to show you what it looks like when we run that job. So what you'll see here is, as the job is running, we have all these logs, and we have one log here called the driver log, and this will show you in real time as the model is running all the output. so that I can monitor the job and see exactly what's going on. You can see this job took about 27 minutes, so that's why I'm not running it from scratch now. And you can see that using the data set that we have pretty strong metric in terms of the F1 score. We can see our aspects, the number of aspects that we have that we want to measure, and the size of the opinions, the sentiments that determine that. And what's really cool is if I click here to see the run in the Azure Machine Learning Studio, we can actually deep dive into the actual experiment. So I'm gonna give that a second to load. And we can also view it here in our experiments. So I can deep dive into the experiments, and here I can see the metrics, I can see all the inputs, but what's really, really cool is I can see a snapshot of my code. So if I have multiple people iterating and changing the model, I can then do comparisons at each point of what changed in my code. If something gets better or something gets worse, and I can work more efficiently across a team. Additionally, again, it's not implemented in this demo, but I have access to see visualizations and explanations using the Azure Interpretability package, which I strongly recommend checking out. If people want more information on that, please tweet at me, message me, or ask a question afterwards. So let's get back to it. Now we've trained a model. How do we actually put that model in production? Well, that's relatively simple. It's just a couple lines of code here. We take run register model. We give our model a name. We tell our to grab it from the outputs of the service that's run. We can even define the framework configurations. We can also talk about resource configuration. So if it's in this case, we don't need a GPU, but if we needed GPU to run the model, we can say that that's what you need in order to run the model. We can say how much memory you need to run the model. In this case, I'm being generous. You can reduce this or increase this, and then we just register the model. So actually, I will show you. We'll just run that, and again, very, very simple. It takes half a second. And then what's really cool is we can do a couple different things. We can take this model and we can run it locally. So I'm going to do that right now. We download the model. We're going to load the model that we've downloaded, and then we can take a look at a couple examples here. So I have a couple tricky examples, like the one that we talked about before. Loved the sweater, but hated the pants. Really great outfit. I really like the shirt. The shoes are bad, but perfect blouse. And you can see here that these these examples would be very, very challenging for a traditional sentiment analysis, but now we can actually run our model, and we can very, very quickly we get that output, and we can actually now visualize how our model works. So we can see that it correctly identified that the sweater is positive, but the pants are negative, which is very, very powerful for getting that granular insight, that here the shoes are negative, but the blouse is positive, something that we couldn't do with an out-of-box solution earlier. The next step would be to deploy this model. So very simple. Essentially, I take the same model that I defined before. We just need to do two things. We need to define an environment. So we tell it exactly what the packages that we used before. Same exact environmental configurations. And we use this to develop what's called inference config. And then what I can do is I create with one line of code the ACI web service deploy configuration, which can pull that information directly from the model. Remember, we said 1 CPU, 2 gigs of memory. And then with just this one line of code, I deploy to my workspace the name of my service, any models I want to use, the inference configuration, deployment configuration, and you'll see that this will now create a service which should be running. So, and then this service, once it's deployed, which takes about 5 minutes to deploy, can then run, and I can either use it and consume it as a REST-based API, or I can even put in a web application here with just those lines of code. So very, very powerful. Now behind the scenes, there's one other small thing that we need to define, which is a very small interface. I just need to define two functions. One is my init function, and the other is my run function. What the init function does is this is a one-time operation that when I spin up the service on deployment for the first time, all the things that I need to do one time, I run them here. And they'll get run again if something happens to the service, if I take it down and I need to start the service. And then I provide the run operation, which is this is exactly what gets called every time I call my endpoint. So it loads my model, processes the text, and returns the information back in a way that I can see this amazing service. So let's go back here and let's continue with one last really, really cool feature of the Azure Machine Learning Service, and that's distributed hyperparameter tuning. So typically, we talked a little bit about this before, that there are two parameters that we're using when we're training this model, the aspect ratio and the aspect threshold and the opinion word threshold. Often when we're training models, there are a bunch of pre-chosen values that are used for configuring the models. And it's really important when we're thinking about production at machine learning to consider that in a research setting, when we just take a model from GitHub, often those models are trained for a specific data set. So for instance, if we're dealing with image processing, you might be using ImageNet. Or if you're dealing with natural language processing, maybe you're using Glue or you're using the Connell data sets. And what ends up happening is when the researchers train their model on their data sets, they choose specific parameter configurations of their models to get the best performance on the data distribution or on the data that they have, but that might not scale to the data that you want to run in your production setting. So what it means is that we need to find new values. Now, traditionally, the way we do this is we provide our own data set, we run the model, we get the results, and then each single time we change a couple of values. Maybe we'll update which model, and every time we change the model that we want to use, we need to do and change all these configuration values again and again and again. And this is, if we're doing this in an iterative process, one after another, it's complex, tedious, repetitive, takes a lot of time, and it affects the performance of our model in a production setting. So the value of a hyperparameter service is twofold. One is it enables us to parallelize the search for the best parameters, and also we also provide support for different early termination policies, whether that's abandonment policy, truncation selection policy, different Gaussian policies. Essentially what these do is they monitor the different runs or the different searching of the hyperparameter space or the different numbers of values that you want for your configuration. And what they can see is if a certain set of values is not converging on optimal results, you can, instead of wasting the compute to train that full model, we can terminate that model early and instead either take the savings back and reduce our costs, which would be amazing, or we can invest that compute back into the models that we think will give us the best configuration settings that we think will give us the best performance. Here's the documentation for that. I'm going to show how we can do that with our own model real quick, and then we'll wrap up. So the way we do this, very, very simple. We connect back into our workspace. We define our compute target to be the exact same cluster from before. Remember that cluster goes from one node, but can scale up to 4 nodes. Then we take our experiment. We define the hyperparameters that we want to search. So in this case, we have the aspect threshold, the opinion threshold, max iterations, the number of iterations or times we want to run the model on the data to make sure that the model is learning. and we can provide a couple different ways of sampling this. Right now, we're going to do a choice, so we can choose a number between 2 to 5. We could also do this over a distribution if we have non-discrete values. Then we define an early termination policy. In the documentation, you can read all about them. For this model, we're going to show a median stopping policy. Essentially, what this does is on a certain number of intervals, after I've trained, let's say, 4 models, or 4 versions of the model on 4 different values of these hyperparameters, what I'll do is I'll take, after a couple iterations, I'll look and I'll take the median performance indicator, the median result, in our case, the F1. And if all the models that are performing worse than that, I will stop them and either spin up new configuration settings or reinvest that compute into the models that are already running. So what we'll see here is we use the exact same estimator that we defined before, but the only change that we have is we use this hyperdrive config, where we pass our estimator, we pass the parameters that we want to search with different values. We provide a primary metric name, in this case, the F1 score that we talked about in the last call. We define whether we want to maximize this value or minimize the value. If, for example, our metric was a loss, you would want the loss to go down. If our metric is something like a traditional metric, like in our case, like F1, we want it to go up. We say how many runs we want to pay for, so in this case 16, and how many we want to run, up to how many we want to run at the same time, 8. And then all we have to do is we do hyperdrive run experiment.submit, and you will see here, I've already run one here. We can take a look at the results, and you'll see what happens, that we can run multiple different configurations and get the results back. So you can see here, this is the result of 16 total runs. We can see each of the values and which ones performed better than others. And we also have a lot of nice, really cool visualizations. So we can see how important it is that you can, and how much the different hyperparameters or different configurations of hyperparameters can affect the performance of our model in production. And then what's really, really cool is, in the same way that we deployed our model before, we can just say hyperdrive.get run by the best primary metric. And now we have our model, and we can do the exact same process to put it in production exactly like we did before. Okay, let's wrap up because we're getting close on time. We covered a lot of ground in this session. I want to go through the takeaways. So the first takeaway is that we saw that AI, specifically natural language processing, is driving a lot of advances in different industries, and specifically across 3 main verticals. We talked about how the Azure Machine Learning Service automates and reduces a lot of the burden from the traditional data science, ML engineer, and ML ops engineer. We talked about the cognitive services and the 80-20 rule of when they're valuable, and also how we can dive deeper and spin off our own more custom models. We talked about how something like text analytics is really, really powerful for taking unstructured data and making it structured, but how also we can use aspect-based sentiment analysis models for even more granular text sentiment analysis. And we talked about how, when we're thinking about taking open source packages like the NLP Architect or a traditional deep learning package through PyTorch or TensorFlow or Keras, we can use the Azure Machine Learning Service to train and optimize that model in a distributed, manageable manner. Everything I talked about here, all the documentation is here. All these slides will be publicly available afterwards. And additionally, we have a lot of really cool demos of how you can use the service in computer vision, recommendation, forecasting, time series forecasting, and natural language processing. Additionally, I've also encapsulated everything that I talked about here in a post called 9 Advanced Tips for Production Machine Learning. Strongly recommend it. Again, a lot of the work here is being added to the Microsoft Learn collection, and I strongly suggest you guys check out Microsoft Learn to learn more about how to interact and work with the different machine learning services on the cloud. And one last final reminder, if you like this content, we've developed a lot of amazing content this month, similar to what I've shown today. And so keep an eye out on our content dashboard, aka.ms.ai April. I'm going to show real quickly the dashboard. Essentially, every single day of the week, we're going to be publishing new and interesting AI and machine learning content. I'll give a quick sneak peek. Just like we talked about natural language processing, I've also done and taken this exact same pipeline that we just discussed, and I can show how it scales to things like computer vision with crowd counting and audience estimation, which is something where there is no cognitive service for that today, and how you can do that with the exact same approaches that we talked about today. There'll be really, really cool posts, so please keep an eye out there. And with that, I really want to thank you guys all for your time. I know it's early in some of the time zones. Thank you for coming and participating. I'll open the floor to any questions in the remaining few minutes that we have.
Yeah, thank you a lot, Ari. It was an awesome content. It was really interesting, and we could see some advanced stuff. And which is why I would like to ask, first of all, could you, get a bit into more details of the early stopping policy, because that might not, be very clear when to apply it, or what does that mean actually?
Sure,
So,
absolutely. Absolutely. So essentially, and we can go back real quickly into the slides to make that. I know we covered a lot of content. So
yes.
Let's go into the slides. So essentially what the early stopping policies enable me to do is imagine I have these values in the hyperparameters. If I were doing this myself, right, I might choose a couple of values. So for instance, we might say that the aspect threshold is 3 and the opinion threshold is 5. I would train a model, and then I would change that. I'd get the results of the model, and then I would change it manually to 4 and 2, and then run another model. And you saw every time that we run this model, it takes 20 minutes. So every single time we do this, very, very quickly, I'm going to use up a day, and maybe in an hour, maybe I can get through 5 of these. But with the distributed service, I can now run 5 in parallel. So I can, instead of in that same, or I can run as many as I want of these different configurations in parallel. So for the same amount of time that it would take me to run train one version of the model, I can train 5 instead of it taking me a full hour. Now the problem with that traditionally is that I'd be paying 5 times what I would be paying to try one experiment. So for instance, if I try 5 different configurations, I have to run the model and train the model 5 times, and I'm paying 5 times for that. And that can get to be very, very expensive. What early termination does is it essentially says is instead, while I'm training this model 5 times, at specific increments, look at the performance of the model. So if I want to, let's say, run the model 50 times, when I look at the performance of the different models that are running, what it will say is it will take, let's say, the median. So one model would perform with a F1 score of 0.8, and another one at 0.7, and another one at 0.6, right? So the median there would be 0.7. And what I would do then is if I would terminate all the models that at that point have a performance of less than 0.7, and then I can reinvest that compute into trying a new configuration that will outperform 0.7, or I can essentially take those savings back and reduce the costs of training. So that's the value of early termination. And there are a couple of different methods for doing that. I won't go into all of them because they're pretty well documented. But if you guys want to learn more about that, feel free to reach out to me. I can send links to documentation.
Yeah, cool. Thank you. So we look forward for the documentations and well, the slides and everything. Thank you a lot. I mean, this content was really awesome, and so thank you again. I think I'm going to wrap it up here. So I would like to thank you for this session, and I hope it was enjoyable for everyone who were joining us. And if you have any questions, you can still ask your questions through the chat we have on the chat.globalai.community, and that is going to be answered. Or the resources will be available soon. Yes.
And feel free again to reach out to me on Twitter, LinkedIn, and keep an eye on the AI April content.
Yeah, thank you a lot. And now we are going to go away for a little break and see you soon with the next speaker. Thank you.